Lesson 1-1, Variables and Expressions. A variable is basically any letter of the alphabet. So we can use, like I said, any letter of the alphabet. It's really common for us to use the variable n and x and y. Those are just common variables to use. Algebraic expressions are numbers, variables, or any combination of numbers, variables, and at least one operation. An example would be something like 2a plus 5. Now that has two operations. Or something as simple as a minus 5. That would also be an algebraic expression. Notice that an algebraic expression does not have an equal sign. That would be an algebraic equation. Ways to show multiplication are obviously something like 2 times 4 with an x representing the multiplication. But we commonly don't use the x to show multiplication in algebra simply because it may be mistaken for an x as a variable. But it's still important to mention it. Other ways to show multiplication include the dot. That means 2 times 4. We could use parentheses to show multiplication. Parentheses could be around the first number, or the second number, or both numbers. We can also put numbers and variables side by side to show multiplication. That does mean 2 times a. We could put just variables beside each other to show multiplication. That meaning a times b times c. Going on. In multiplication, the quantities being multiplied are called factors. And the result is called the product. In our examples that follow, we are to write an algebraic expression for each verbal expression. Number 1 is 8 more than a number, which would be 8 plus n. You can use any variable you like there. As long as they're not specifying which variable to use, you can make up any variable. Number 2, the difference of 7 and 4 times a number. Remember the phrase, the difference of means subtraction. The word and tells us where that subtraction belongs. So this would be the difference of, meaning 7 minus 4 times a number x. Number 3 is 5 less than a number c. 5 less than a number c means that the 5 needs to be at the end of that subtraction problem. And lastly, number 4, 1/3 of the size of the original area A. In this case, this of means multiplication. 1/3 of the size of the original area A is simply 1/3 times A. On the back side of your notes, we deal with powers. That statement, x to the n, is called a power. Some people want to say that it is an exponent. That's not true. This is the exponent. That little raised n is the exponent. And the big number, in this case the big X, is also known as the base. The exponent indicates the number of times the base is used as a factor. Our first problem here is 5 to the first power, which means that there are 1 5s. It seems silly to say that, but there's 1 5 that's being multiplied. So 5 to the first power is just 5. This would be 5 to the second power, meaning 5 times 5. 5 times 5 is 25. But we can also read that another way. Instead of saying 5 to the second power, we could say 5 squared. The next problem is 5 to the third power, which means there are 3 5s being multiplied. 5 times 5 times 5 is 125. And very similarly to 5 squared, 5 to the third power can be read another way. It can be read as 5 cubed. Next, 5 to the fourth power, 5 times 5 times 5 times 5 is 625. And lastly, 3 times w to the fifth power, we cannot evaluate that because we do not know what w equals. It would simply be 3 times w times w times w times w times w. In the following examples, we are to write each expression algebraically, which means numbers, letters, and symbols. Number 1 here says the product of 3/4 and a to the 7th power. We know product means multiplication. The word and tells us where that multiplication should be. This is 3/4 times a to the 7th power. Number 2, the sum of 11 and x to the 3rd power. Along the same lines, we know the sum of means addition. The word and tells us where that addition sign should go. The sum of 11 and x to the 3rd power. The next 2 examples ask us to evaluate, so let's be sure to show our work, and that's just simply writing out what we're doing in our calculators. This is 3 to the 4th, 3 times 3 times 3 times 3. 3 times 3 times 3 times 3 would be 81. Number 2 is 8 squared, which is 8 times 8, which is 64. Easy peasy. In the very last 2 examples, we're asked to write a verbal expression for each algebraic expression. Remembering here that verbal expressions just mean write it out in words. So if I read the problem out loud to you, I've basically given you the answer. This would be 8 times x squared divided by 5. And of course, you can use other words to describe the multiplication, or to describe this division, or to describe the squared. Just make sure that you spell each word out, that you don't write the number. Make sure you do spell it out with a word. And the last example, y to the 5th power minus 16 times y. The way people miss these is that they might say 16y, because it's typical for us to say that to each other when we're reading the problem to our friend. But we all know 16y means 16 times y. In writing a verbal expression, we have to indicate each operation, so leaving out the word times would make this problem wrong. I hope you've enjoyed this lesson. Tune in again.